Okay, welcome everybody. This is Networking the Service Mesh Proxy, where we are, where we're going. I'm Tim Swanson.
And I'm John Joyce. We're from Cisco. We're in the Cloud Platform Solutions Group, and we're also maintainers of the Istio-cni.
So this is almost the last session of the day, so hopefully I'll keep you guys awake. We do have an agenda. It's pretty long, but we really are just the main point is we're gonna focus on, we're not gonna go through Istio, okay? So if you're expecting an overview of Istio and Istio features, you're not gonna get it here. We're gonna focus on some specific problems in networking the service mesh proxy and various approaches in different communities. So when you see pictures of service mesh, basically you see an application and a proxy that's hosted very near it, connected to another proxy back to another application instance. And when I first saw that picture, the thing that struck me was, how the hell do they do that little arrow right there? So between how does all the traffic get to the proxy? So there's a lot of techniques for that. And it's really related to the way that proxy is injected. So in the environment that the proxy and the application instance are running in kind of drives how that works as well. So there's multiple layers here for this problem. We're going to kind of go through some of those. And then the actual solutions and the advantages and disadvantages of the solution mostly fall in the category of what works in the most places, maybe some performance improvements, and a big one is how does it integrate with existing application and proxy orchestration solutions. So for we call it traffic redirect, how the traffic ends up in the proxy and how the proxy ends up pushing all the traffic back. So the most common solution you'll see is IP tables. And there's support for IP6 tables added in some solutions, Istio being one. And then evolving is our eBPF solution. So the Cilium project has a solution that works with T-proxy. So basically they use IP tables, T-proxy target to put the proxy right in the raw IP table. And so the proxy, there's no TCP connection tracking and stuff like that in the Linux stack. So that's a good stuff. And then they're going further in the Cilium project with socket redirect. So basically just connecting the application socket with the proxy socket. And then another approach, more in line with some proxy orchestration techniques, is using a host vSwitch a solution similar to like a service function chaining. And then for orchestrating the configuration of these different approaches, there's actual multiple options there. So the main one that like Istio and Linkerd, or I guess Istio supports is having a init container that has netadmin permissions and that does the IP table setup. We created a CNI plugin that does the same stuff, but it does it in the CNI layer. And then there's a project called NSM that would be possible to use for injecting a proxy, injecting like an interface into a pod and connecting a proxy in with that. And then if you're a VM or a bare metal node, there's a node agent that would handle deploying doing all the traffic redirect setup for that. So those are the basic solutions. For the proxy lifecycle, there's also multiple solutions for that. And these are in various stages of development or proof of concept here. The main one that everybody seems to use right now is the admission controller approach with a mutating webhook, and it injects a sidecar, and Kubernetes manages, bringing up the container for the proxy and all that stuff. The disadvantage of that is the init container is not networked through the proxy, so none of your security stuff that you've done for that pod is going to work on your init container. And maybe the solution for that is to start the proxy in the CNI. So the CNI would basically start up a proxy process, and the advantage there is that before anything runs in the pod, the whole proxy network is set up. An alternative is the network service mesh solution, which could be used to cause a proxy pod to actually show up on the same node as the application instance, and then wire those together. That's still just theory. Nobody's done that yet. And then the node agent thing that I was talking about, that could be used to also just bring up a proxy. So we're going to quickly go through some CNI. So we're going to get into CNI layer stuff. So we're going to quickly go through what the CNI is, and I'm not going to really go too deep in here, but what we have, what the CNI is it's a spec. So it's a spec for, so people can write plugins that are just responsible for plumbing containers into a network. And the spec calls for the ability to chain plugins. So you can have multiple CNI plugins run on the same container namespace creation. And the most common best practice for installing these plugins in Kubernetes is with a node a daemon set. So a per node pod that is responsible for configuring the kubelet with the whatever config for the plugin, and for putting the binary into the kubelet's execution path. So now we're going to talk about Istio-cni. So Istio-cni was created because the Istio project had used an init container solution that required netadmin privileges, and that violated a lot of pod security policies or administration, who can do what. So the current project is really tightly coupled with Istio, so it's driven by Istio features and reviewers and contributors. It takes advantage of the CNI chaining that I just talked about to plug a CNI plugin into an existing CNI configuration. So it doesn't actually do any full networking itself. It's just responsible for doing that redirect I showed in that picture. So it installs via daemon set, like I told you the best practices were. So the way it works, so this is the visualization of the CNI plugin chain. We have each node has a daemon set, and that daemon set sets up an Istio-cni config in the existing configuration on that node for the CNI. So the kubelet, when it runs, when a pod is coming up, it runs each one of these in the chain, each plugin that's in the config chain. And the Istio-cni is doing this, right? So it's setting up IP tables to make that traffic redirect happen. So how does the IP tables work? So this is kind of a dense slide, but the gist is that DNS traffic, when the app makes a request, DNS is not TCP, so it's gonna end up getting routed on the network, and vice versa when it comes back. If this app is a server, so he's going to have some ports open, and the excuse me, the NAT pre-routing chain is going to have those ports configured in rules, and assuming, so Istio and Linkerd mostly operate on TCP traffic, so that's going to be, or only operate on TCP traffic, so that's going to end up falling in this check, and it's going to get redirected to the proxy. So there's in IP tables, there's a redirect target, and that redirect target is kind of like a NAT function, but it doesn't modify the packet. So the proxy sees the actual dest address and port and stuff. So this redirect is just to a port that this proxy is listening on. So all the traffic ends up in the same port in this proxy. And similarly, on the outbound, the NAT output chain is going to, when the proxy is going to send to this app, the output chain is going to notice, hey, this is the proxy PID sending this. So we're not going to do the redirect back to this guy. So it's going to end up in the route target and end up back in the app. And when the app sends its traffic, it's the same chain. It's just a different representation of this chain, of this picture. So it's the NAT output chain again. The owner is not the proxy, and it's going to end up getting redirected to the proxy. And then the proxy is going to do its thing, and then send out through the same NAT output chain, but it's going to fall under that rule where the PID is actually matching the proxy. And we hit the route, and it goes to the network. So it relies on the ability to see the PID for that proxy, the redirect target, and then it knows the rest of it's basically just port catching. So Istio-cni Features, they're really, we do support parity with the init container. So it does include T-proxy support for working with Cilium. It's compliant fully to the CNI spec, and it has, in the way Istio gives it parameters is via annotations on pods. So when there's an injection of a sidecar, this CNI will notice it and do the action on that pod, and it won't do it to the other pods that don't have those annotations. So in the future work, I talked about doing the lifecycle of the proxy in the CNI, and that's, there's an engineer named Marco Luxa from Red Hat. He's got a proposal for that, actual code, so we're looking to get that in soon. But it needs some shaking out. But the gist is that when the CNI runs, it's going to start a Envoy or a proxy instance in the same network namespace as the pod, and it's going to then set up the IP tables for that. And that'll avoid that init container problem that I talked about, where the init container will be networked exactly the same as the application. So your Istio rules that you put on the app pod will apply to the init container as well. The cons for that are obviously that this is not going to be in the pod spec. So the Envoy process is invisible to Kubernetes. So something, if you're going to, you have to account for it in your resource reservation, in your pod spec, and there's going to be, we have to have some alternate method for monitoring that proxy that we would have to create outside of using Kubernetes techniques.
Okay, so I'm going to shift gears quite a bit here and talk a little bit more about how the Istio-cni relates to other projects, or how we might want to make some of the functions that we did with that Tim was describing in CNI does, how we might want to do them differently than he just described. So the first and most obvious one is, how does this relate to Linkerd? So we've had some interaction with the Linkerd guys, and as I believe they've mostly borrowed our code almost verbatim for how we did it, and they've adopted that, and they have that as a feature that I think is in a beta stage for them. So we have talked to them about actually trying to make this a common repo in some way or make the code entirely common so it's shared. We're not quite there yet, but that's something that may happen. So the other one that you probably heard a lot about this week, there's been some keynotes, a number of other sessions, is the network service mesh. It's an incubation project. There are some possibilities that we could integrate with the network service mesh, and we could have the network service mesh do some of the functions here, or have some of what the network service mesh does, have Istio or service, like an app service mesh, plugged by the network service mesh itself. So we'll talk about that a little bit. The other one that Tim referenced quite a bit is how does this integrate with Cilium and eBPF? In the case of Cilium and eBPF, a lot of it's more about performance and how you can change sort of the data plane, the actual data plane that's used to move the packets around versus the actual process and orchestration. But we'll talk about that a little bit too. So first, a little bit of a summary on NSM. So probably most people have heard about this already this week, so I'll try to go a little bit quick here. But network service mesh is very different than what we sometimes refer to as just service mesh or app service mesh, like Istio or Linkerd. Network service mesh concentrates more on the network level and how to provide basic network connectivity and network services between, along the lines of a connection or between endpoints of a connection. So it's less about how the app might want to do all its work, and more about how the network is constructed between a source and a destination. The way it does this, though, is it tries to be fairly integrated with Kubernetes and tries to determine the requirements of the connection and the constraints of the connection via annotations and other Kubernetes types of resources or definitions, so that it tries to be integrated tightly with Kubernetes. In the case of NSM, there is no type binding to a data plane. Most of the data planes that we've seen people have been using with network service mesh or like a vSwitch oriented, but it's not bound to any type data plane, so it could be used with other data planes. So this is just a quick sort of topology view borrowed from the network service mesh documentation itself. There's a client that's run or closely coupled with the application itself to actually create a connection and tell the network service manager what kind of connection it wants. The network service manager itself is a daemon set that will actually set up the connection. I show a network service endpoint here. That could be a function like a VPN or a firewall that represents some kind of in NSM lingo, it's called a network service endpoint, but what it does is it provides some kind of network function that might be required in the path of a connection. The registry keeps track of those network services and the network service endpoints so that they can be inserted in the chain. So this is just a quick example of what might happen, again, using some of the network service mesh language, but the idea is that a user called Sarah might need a connection to the corporate internet, and she doesn't want to be too bothered with what kind of constraints or requirements that connection has, but she has, a network admin and a security admin and other constraints that will be imposed on her, and those constraints can be imposed through configuration and annotations in Kubernetes, so she doesn't have to be aware of them. But when her app or her service requests a connection, the network service mesh will orchestrate the adding these other elements, like I show here, like a firewall or a VPN. So how does this relate to the CNI? So at the current time, there's no actual integrations or proof of concepts to do this work, but it sort of falls out naturally if you think about it, that if the network service mesh is actually orchestrating what kind of network elements and services need to be in the path of a connection, it could easily, or quite easily, you could envision like what we talked about with the CNI falling into that same pattern, where it's, hey, this particular application wants to be part of a service mesh. Let me network in a proxy let me have that proxy get its configuration from a control plane like Istio or Linkerd or whatever. And that represents, you can think of that proxy as just a sort of another network function that the network service mesh is aware of that needs to be inserted for that particular service. And it could maybe if the app or that particular pod is doing different types of services, maybe that proxy is only inserted for some types of traffic and not others. So again, this is all sort of speculative, but you know, one thing that we're going to explore a little bit with the network service mesh guys is whether there's anything that should be pursued here and whether this should be more formalized. So quickly on Cilium, we've actually talked about this a little bit too. With the case of Cilium, as I said, the biggest play here is that this would be, could be a much more performant way to connect the proxy and the app together. You can, IP tables is not very performant. It's quite well known. It's quite easy to deal with, but it's not very performant. So the first and obvious thing is, and the Cilium guys have, unlike the NSM stuff, a lot of this does exist. The Cilium guys do work with Istio. They do are able to plug in proxies. They have a couple solutions available for that. So one thing that the Istio team is interested in with the case of Cilium is actually having a tighter integration with eBPF. Well, I shouldn't say Cilium specifically, more tighter integration with eBPF. So eBPF is an option to plug in the proxy to get better performance. So that's something that the Istio community has been actively talking about and very likely to pursue more actively in one of the upcoming releases. So as Tim was referring to, there's sort of two ways that they approach this. They can do a transparent proxy or a socket level redirect. And I show the three variants here. On the left here is the traditional IP tables. You see we pass through IP tables twice, through the TCP stack a few times. Then when you do the transparent proxy, you get one level of performance boost in that you're not actually passing through IP tables. And you've reduced the amount of the stack that you have to go through. And then on the right is an even greater opportunity for performance boost. So I guess in summary, between these three methods that I talked about, the Linkerd method, that's already in the works. They have something almost identical to us, but it's not, those two projects are still separable and the code base is separable. So there's an opportunity perhaps to combine that. NSM is all exploratory, but it's something that we could look at to see how that meshes with the NSM, sorry about the pun. And then the Cilium stuff is, has been actively talked about and likely to actually see some more specific developments available over the next couple months. So again, this is just a sort of summary back to, we showed this slide earlier, just showing a summary of where we are with the different approaches, some of the pros and cons of the different options and what we're doing and where we're at with them. So I think at this point we're...
Yeah, I just wanted to add, I mean, the work of like where the proxy, who instantiates the proxy, that's probably the biggest like discussion point on what's going on, what should be the future. There is a lot of momentum behind having like the CNI do it, and actually Cilium has really integrated Envoy, and there could be some, their model when they do their L7 policy is a little bit different than the per sidecar model, but it could be probably adapted to that. So there's some definite, or you know, maybe the Istio-cni just becomes the thing that starts the proxy. So that's probably, if you're wondering what's going on in the community, that's probably the biggest change that would impact most of you Istio users out there. So the final slide is really just our references from the thing. Again, a lot of these references are from open source groups. Also, where the CNI project is, we more than love anybody to help contribute. It's a fairly small team. There's not a huge amount of work either, so it's very easy to get right in there and do some
PRs and do some contributions and be one of the leads.
Yeah, one of the IPv6 main contributor here is here, and we're possibly going to move to NF tables from IP tables. So there's things that could be done. We might there's the way that the IP tables are played out is using the IP tables client, not so the executable rather than like a Go library. So there's potential for changes there. So there's a lot of cut your teeth kind of things that could be done pretty quickly, and but it's a great place to learn, I think, if you're a new contributor especially.
So that's it, except for questions. Does anybody have any questions?
Did a really good job, man.
Yeah. Either that or everybody's asleep.
Yeah, everybody awake? Need like a DJ?
I think we got the group that don't have their flights yet.
Yeah, so this is like camping out.
It's more comfortable than the airport lounge.
The luggage area was full in the lobby, I think, so this is, check your bags here. All right,
Okay, great.
If you have any other questions, just grab me in the hall.